Ladies and gentlemen, welcome back to my YouTube channel. If it's your first time, don't forget to subscribe, to like and share. Okay, so in today's video we'll be talking about kinematics. So, and the topic which is under consideration is what? Motion in what? In one dimension. Yes, so motion in one what? Dimension. So motion in one dimension is nothing but what? Motion in what? In the straight what? Line. E.g., a car in the what? In the straight road. That is motion in what? In one dimension. What? Car in a straight what? Road. That is motion in what? One dimension. That's a good example. So let us try to define the following terms. Yeah, we can talk about motions without some important definition like distance. What is distance? How do you define distance? Yes, so distance is the what? Is the total what? Total length of the path. What? See? Total length of the what? Of the path traveled what? By the body. Yes, that is the distance. Then it was defining what? Displacement. Yes, so then don't forget that distance is what? Is a scalar, is a not rather a scalar quantity. Sorry for the strip of the tongue. It's a scalar quantity because it doesn't have what? See? Direction. Yes. Distance is just what? The total length of the path traveled by the body in what? In a given time. Let us say in a given time. Then displacement. Displacement is nothing but what? See? The total distance traveled by the body in a specific direction. Total distance traveled by the body in the specific direction. Hope you can now tell the difference between displacement and distance. Displacement has what? Direction. So displacement is the total distance traveled by the body in the specific direction. Yes, you can easily define that. Then let us try to define what? Velocity. Velocity is what? Is the change of displacement in the what? In the given time. Yes, that is velocity. Yes, and the acceleration is the what? Acceleration is the change of what? Of velocity. Change of velocity in the given, or let's just say at the what? Let's just say in the given what? Time. Yes, that is how we can define acceleration. Now let us try to, okay, we from here we are going to talk about yes, let us first let us talk about what? Motion in the what? In the the vertically motion in vertically. So with, from here, let us just try to answer some examples in concerning what motion in the in the horizontal. But see, don't forget here there are just, let me just say, 4 important equations that you have to know. Yes, if you have time, I'll make a video about how to drive them, but for the sake of time, let me just write them down here. So the first one, we have what? Acceleration is equal to what? Final velocity minus initial velocity over time. The second one is what? The second one is velocity is equal to initial velocity plus acceleration times time. The third one is equal to what? Is given by displacement is equal to what? Initial velocity times time plus half times acceleration times time squared. And the last one that we are going to talk about is the velocity is equal to, so velocity squared, final velocity squared is equal to initial velocity. So this, we use this subscript to denote what, to differentiate between final and initial. Yeah, so squared plus, yeah, these are the important equation that you have to know. Yes, so from here I have an example. Let's try to look at this example. Yes, let us try to look at this example. Yes, so this is the example. So yes, after you write these equations, you just have to know them, these equations. Yes, so this is the example. Just as a car starts to accelerate from rest at a constant rate of what, 2.44 meters per second squared, a bus moving at a constant speed of 19.6 meters per second. Yes, this 19.6 meters per second passes a car in a parallel lane. Yes, in a parallel lane. Yes, again I read the question. Just as a car starts to accelerate from rest at a constant rate of 2.44 meters per second squared, a bus moving at a constant speed of 19.6 meters per second passes a car in a parallel lane. So the question, how long before the car overtake the bus? That's the first question. Yes, so let me just use this another part, pen paper. Yes, so the first question is saying, so you have to understand this, it's happening here simultaneously. So you have said just as, you understand, you get the concept. So they are saying how long before the car overtake the bus. So they want what, how long. You can even tell that they're talking about what, they're talking about time. Yes, so let's go. Solutions. So let us collect what, let us say data. This is very important in what, physics. So that, let us say car and what, dealing a car and bus. Let us write for the bus here, bus. So just as a car starts to accelerate from rest, so we can tell that the initial velocity is equal to 0 meters per second at a constant rate of what, of 2.44 what, meters per second. So the acceleration is equal to what, 2.44 meters per second squared. And we have to find the acceleration as the change of what, of velocity. So which means when it started from rest, the velocity was changing at this rate. So then time, we don't know. Then let us go to the bus. The bus is moving at a constant speed. The constant speed, so that's the initial, that's its initial speed is what, 19.6 meters per second. That's its initial speed. Then passes what? Passes a car in a parallel lane. This is the data we have. When something is moving at a constant speed, which means it doesn't have what? Acceleration. Hope it's making sense. Yeah, when something is moving at a constant speed, that means it doesn't have acceleration. Yes, so acceleration is equal to what? 0. Yes, because see, so at the constant, this speed was just keeps on what? The bus kept on what? Going the same speed. So the acceleration there is 0. Hope it's making sense. It's making sense. Yes, so from there, we can now see, we can use this equation. We have what? We can say, from there, we can say what? We have, let us use, that's why I was saying these equations, these ones, they are very important. You should take note of these equations. Yes, they're very cardinal. So let us use this what? See, this equation squared. So let us try to insert for the what? For the car. We are on the first question. So for the car, we know that for the car, it's moving at the what? At 0. Then this is at 0. It started from 0. So this is initial speed. This is the initial what? Initial velocity and time. Then this is the acceleration. This is time again. So we know that this would definitely be 0. So our equation will be reduced to what? To this. And for the bus, we write the same equation. But we know that the acceleration for the car is 0. Yes, this is because this is acceleration, but the acceleration for the what? For the bus rather, for the bus is 0. So this will be eliminated from our equation, and our equation is going to be simplified to what? To this. Yes. Now we know that here now that's where the concept comes in. Yes. Here that's where the concept where the what comes in. We know that see, the distance when the what? See, these two, the distance to be traveled in that time is going to be the same. The distance that will be traveled in that time is going to be the same. Hope that's making sense. So we are going to equate these two. We are going to say 1 over 2 acceleration squared is equal to what? See? But we know that this is the initial what? The initial velocity for the what? For the bus, which it was what? It was moving at. So we know that, see, no, it's not squared. It's not squared. Yes, because this was eliminated, remained with this. So we know that this time is common. Will be common. So this time and here time, what? One time will be what? Because it's like we have time times time here. You see. So when we cancel t, this t here and the one t will be cancelled here. So we remain with it. Squared is equal to this. You have seen, okay? When we just use this, we can just say, when we multiply through what? Through 2 here t, we are going to remain with 1 t. Sorry, we're going to remain with 1 t. So you want to make t subject to the formula. So we are going to multiply through 2 and divide by what? Acceleration, so that the t remains alone. So let us divide by what? Acceleration, so that this and this will go, this and that will go, and this times that. So here we remain with it. C is equal to 2. This is U stand for initial velocity for the what? For the bus, and over acceleration. Then here we just plug in. Let us plug in what we have. Let's try to plug in 2 times what? 19.6 times what? Over acceleration is acceleration for the what? For the car. Yes, that's the acceleration. I hope you have driven is correct. Yes, we are correct. So we are going to say 2 times 19 times 19.6 divided by 2.44. Yeah, it's giving me 16.07 seconds. That's the time. According to this question, how long before the car overtake the what? The bus? it will be what? 16 seconds. Yes. Yeah, you have seen. We started from here. We started from here. You can go through. Yes, up to there. Yes, that's the thing. So now another question reads, how fast is the car going then? So we want to find the speed for the car. Yeah, because the change of it in what? Or change of what? Change of displacement. Yes, that's the, because it started from what? It started from less, so the speed was 0. How is the displacement changing with respect to time? You understand that? So we want to find the speed, that's the velocity. So that is what? B. Yes, that's the question. How fast is the what? How fast is the car going then? So that is what? That is the velocity. So you can use what? This equation I gave you. This equation I wrote here. I wrote something here. So we are going to use, yes, we are going to use this one. This is the what? See? This is the equation we are going to use. So this is very simple. Here we just say V is equal to initial plus what? See? Yeah, so we know that the car, this is what? 0. So we have acceleration C. That's how it's going to be reduced. And the acceleration for the car is what? 2.44 times 16.07. Yes, that's the time we got. We just multiply 16.07 times 2.44. It's giving me what? 39.2 meters per second. Yes, that's how fast is the car going then. How far? Then the last question reads, how far is the car gone at that point, at that time? What is the distance, the total distance traveled by the what? By the car. So due to space, let me just solve it from here. I'll just solve it from here. The last question, I'll solve it from here. How fast, the question is, how fast is the car gone at that point? So this question is simply telling us to find the distance traveled by the what? By the car. So we will use the same formula. Squared. Then we know that it was starting from left, so it will be reduced to this. This will be eliminated because here when we put 0, that's starting from left, so we're going to put 0. This will be eliminated. Acceleration we know is 2.44 times the time. We use the same 16.07 squared. Then we just compute this. So 0.1 over 2 is 0.5 times 2 point, let me just start again. 2.44 times 0.5 times 16.07 squared is giving me 315 rather point, let me just say 1, yes, meters, because that's what's distance. Yeah, that's for this question. That's for this question. Now let us try to, I wanted to answer another example concerning this. Now let us try to look at what's free fall. Yes, let us try to look at free fall. I want to solve even for free fall in the same video. Yes, hope this is making sense. Let me just try to solve for free fall. Yes, let's try to look at something different. Free fall, the motion in what? Vertically. Yeah, because we're dealing with horizontal. You have answered. Now let's try to look at what for the one which is happening vertically. So free fall is the example of what? Linear motion with constant what? Acceleration. Just an example of linear motion with constant acceleration. Now it's happening. It can happen up or down. For example, when you drop something from a certain height, or you project something from the ground, And what happens here is that, so let me just say free fall. Let me put this aside. Free fall is what? Is the vertical what? Vertical motion of the body. And okay, let me say, is what? Is influenced by what? Is influenced by what? By gravity. Yeah, it's influenced by gravity. Free fall, yes. So when you, for example, when you project something upward, let me say upward, the what? The velocity decreases. Velocity decreases at the rate of what? Of 9.8 meters per second squared. You understand? Then when you what? When you drop something, let's just say what? Down what? Downward. Downward, what happens when we are dealing with downward? The velocity increases at the rate of what? At the rate of 9.8 meters per second squared. These are the important concepts that you have to what? That you have to understand. Yes, these are the, yes, and yes, we have said that free fall is the vertical motion of the body. Yes, but yes, vertical, and it has the acceleration of what? You can conclude it has the acceleration of 9.8 meters per second squared, because according to the concept that we have defined here. So now let us try to look at some of the examples. I hope this is making sense, guys. Just try to understand. Just try to follow you, grasp the concepts. Yes, let us try to solve one example of what? Vertical motion. Yes, this is the question. So the question read, a ball is thrown vertically upward with an initial velocity of what? 1.5 meters per second. Determine how high, yes, how high it will go. How high it will go. If, sorry, this is if, how high it will go, sorry, that's how it's going. How high it will go and how long it will take in air. Yes, if air resistance is ignored. A ball is thrown vertically upward with an initial velocity of 1.5 meters per second. Determine how high it will go and how long it will take in air. So let us say that this is our data. Yes, this is our data. We can say that is, so initial velocity is what? 1.5 meters per second. Acceleration is what? Vertical motion always due with the acceleration due to gravity. 9.8 meters per second squared. Use G to denote what? Acceleration due to gravity. And we know that when, since it's projected what? From the ground, as this goes upwards, it will reach at the point where the final velocity is going to be equal to 0. Because we have said what? Upward velocity decreases at the rate of what? Upward. The velocity decreases at the rate of 9.8 meters per second. So the final velocity will be 0. So we want to find how high. We can use this formula. That's why these formulas are very important. Will this formula help us you ask yourself, is this formula going to help us? So this formula is definitely not going to help us because we don't have time just to say to use this one. Let us use y. We use y since we are dealing with the vertical. We use y. Yes. So we know that this is 0. We can put 0 here. And the initial velocity was what? 1.5 squared plus 2 times it's upward, so it's supposed to be what? Negative 9.8. So we put what is going against gravity, upward, so we put negative. Then y, that's what we are looking for. Yes. So 2 times 9.8. So we're going to say 2 times 9.8. 2 times 9.8 is giving me square root is equal to, let me say negative here, negative 9.6y. Then this will cross the equal sign since we have 0 here, and we're going to have 19.6y. Yes, that's the wrong mathematical, so it's cross. We say we add both sides, so then we have 1.5 squared is what? 2.25 over 9.6 over 9.6. Then I'll continue from here. This and this will cancel. Then you're going to have y will be equal to what? Y is going to be equal to 2.25 divided by 19.6. It's giving me 0.115 meters. Yes, this is what it's giving me. Then I'll just answer the last one here. The last one is saying, and how long it will take, how long it will take in air if what air resistance is ignored. So we know that when we project something, if air resistance is what is ignored, the time it will take to go from the bottom to the maximum height is the same time it will take to what, because the rate is the same. The rate of acceleration is changed. The rate at which acceleration velocity is changing is the same. So the time it will take from the ground to the maximum height and the time it will take from the maximum height to the ground will be the same. So we are going to say, since we want time, so we have this equation. Once time, what are we going to do? We subtract what? This from the both sides, so that we have, yes, so that we have what? Gt is equal to what? V minus u over g over g. This is the acceleration due to gravity. Time will be equal to v minus u, the initial, and we subtract. We substitute. This is 0. We have what we have said. We have said at the maximum height it will be 0. Then here we have what? 1.5 over negative what is, it was going upwards, so it should be negative 9.8. This and this will cancel. Then what I have 1.5 divided by what? It's giving me 0.15 seconds. Then since we want how long it will take what's in air, so the total time it should be in air. That's the time we want. So since the time this is the time it will take to go from the bottom to the maximum height, and the time it will take here, since it will be the same, let us just multiply by 2. So just say 2 times 0.15 times 2 is 0.3 seconds. That's the total time.